Welcome to
SummerMath number 2.
SummerMath number 2. So we stayed in our section 1.2 of our Art of Problem Solving's Intro to Counting and Probability. And this was one of the homework problems, which was a pretty cool problem.
Yeah.
And you actually had a nice solution to this. So I want to talk through how you did this problem, because I liked the solution. So go ahead. Well, what?
First I converted all these numbers to improper fractions.
Sorry, before we started, I didn't even write the question down. The question was, how many numbers are in this list?
Right.
Sorry for not writing the question down. 3 2/3, 4 1/3, 5 2/3, all the way up to 27. Okay, so how many numbers are in this list?
Well, I converted to improper fractions.
Okay.
So you get 11 thirds, 13 thirds, 15 thirds, 17 thirds, all the way up to, well, this last one's 81 thirds. This one's 79 thirds.
Okay, so stop there for a second. How did 5 become 15 thirds?
Well, 15 is 3 times 5.
Ah, okay. And how did 4 1/3 become 13 thirds?
Well, 4 1/3, you can convert 4 to 12 thirds.
4 is 12 thirds, and then plus 1/3 is
13 thirds.
Okay, awesome. So we have this list is the same numbers as this list. 11 thirds, 13 thirds, 15 thirds, 17 thirds, 79 thirds, 81 thirds.
Yeah.
Okay. What'd you do next?
Well, then I just got rid of all the 3's because they're on every bottom and they don't really matter.
Okay. So what do you have now?
11, 13, 15, 17, all the way up to 79, 81.
Okay, now, why can we do that?
Well,
What?
because we're doing the same thing to every term.
Okay, but they're not the same numbers.
Yeah, we're not like introducing another term or anything.
Ah. So although we're changing the numbers from this step to this step, what we're trying to do is find how many terms there are, and this sequence has the same number of terms as this sequence.
Yeah.
Right? We haven't changed the number of terms. Okay, what did you do now?
So then I wrote all the numbers from 11 to 81.
Okay.
11, 12, 13, 14, 15, 16, all the way up to 79, 80, 81. Here there's 71 numbers.
Okay, well hold on a second. Now you have changed the number
Yeah.
of numbers,
Yeah.
right?
I added
But it is easier to count every single number.
Yeah.
Okay, and how did you figure out there were 71 numbers here?
Well, I subtracted 10 from each. You put 1, 2, 3, 4, 5, 6, all the way up to 69, 70, 71.
Do you see that?
Yeah.
Okay.
Then I grouped them. So I grouped them in odds first, evens next.
Okay.
And I'm able to group them like this. And since you have 71 numbers, this one's the odd one out. So you can say there's 70. You've got 70 numbers in groups.
Okay.
Which means there's 35 groups. Plus the odd one out, so 36 numbers.
36 numbers where?
In this.
In that, which is the same as the numbers in...
This.
There you go. That's a pretty cool solution, isn't it?
Yeah.
Good job. Did you like that?
Yeah.
Well, that's a pretty fun problem. Were you able to do this problem too?
Yeah.
Yeah? How'd you do it?
Well, I just counted all of the numbers. Kogan noticed that they were incrementing by 2 thirds.
I see, and then you just counted them.
Yeah.
Okay. Yeah. You know what's a good strategy when you're counting?
Count.
Counting.
Counting.
Yeah. Hey, good job. All right. Good job this morning, guys.